At this point, we will start machining the part. We will machine the two steps using a contour toolpath. A contour toolpath removes material following a path of curves. Contour toolpaths only follow a chain and they do not clean out an enclosed area. To select toolpaths, there are three different ways. The first way is to select the toolpath from the Toolpaths menu, Contour Toolpath here. The second way is to right-click in the Operations Manager, select Mill Toolpaths, and choose Contour. Or you can choose the icon located here to the left-hand side. Select one of these three options to create a contour toolpath. Then select the OK button to accept the default NC name. Now the chaining dialog box will appear. Ensure that the chain button is selected, and select these two chains in the direction as shown. If you need to flip the direction of the chains, you can click on the reverse button here. Chaining is important because it determines the direction the end mill will move across your part. As well, it determines whether or not you are climb milling or conventional milling. Select the OK button to exit the chaining dialog box. The Contour Toolpath dialog box will appear. Along the left-hand side, you will see different menus that you can select, some quick view settings below that, and the corresponding pages in relation to the menu that you select here. Here, the Contour Toolpath should be selected as your toolpath type. Select the Tool menu. Note that a tool is not selected. Click on Select Library Tool and disable the filter. Click on Diameter to organize the tools. Then select a 3/4 inch flat end mill from the tool list. Tool number 241. Select the OK button and note that the tool number is automatically changed to 1 based on the tool setting option that we selected. Assign tool number sequentially. Enter in the comment. In the tool page, we can change the tool number, the length or diameter offset, the head number, the tool diameter and a quarter radius if the tool has one, a feed rate, a spindle speed, feed per tooth, surface feet per minute, a plunge rate, and a retract rate. We can also indicate whether we want clockwise or counterclockwise spindle direction. Feed rate sets the rate at which the tool moves through the material. Spindle speed determines how fast the spindle revolves per minute. Feed per tooth sets the amount of material removed per flute. Surface feet per minute displays how many feet per minute the tool will cover. Plunge rate sets the rate the tool will plunge into the material at, and retract rate is how fast the tool retracts out of the material. Select Cut parameters. On this page, we can set our compensation type. This determines the tool compensation, adjusting the toolpath to allow for cutting tool's radius. There are 5 different types of compensation. Computer automatically calculates the compensated tool positions based off the dimensions in Mastercam. Control uses the machine's control to calculate the positions instead of Mastercam. Using this option will output G41, G42 in your NC code. Wear has Mastercam calculate the compensated tool positions, but also outputs a G41, G42 code. This lets the operator adjust for tool wear at the machine. Using this option, you would input the difference between the selected tool size and the reground tool size at the control as a negative number. Reverse wear works just like wear, except the wear adjustments are input as a positive number. Off, Mastercam will not compensate for adjusting the tool's position. The center of the tool will go down the selected chained entities. For all of our tutorials in Mill Level 1, we will be using Computer. Set the compensation direction to right. This determines which side of the chain the tool is on, based on the chaining direction. Roll cutter around corners set to sharp inserts arc moves around the corners in the toolpath. The radius of the arc moves is equal with the radius of the tool. Infinite look ahead prevents the toolpath from crossing itself. Stock to leave on walls and floors leaves a specified amount of material on the part to come back with a finish pass. Contour type sets the type of contour toolpath. There are 7 different contour types based on the selected geometry. Now select Lead In, Lead Out. Lead In, Lead Out dictates how the tool will enter or exit the part. Disable an entry move and an exit move. Enable Adjust Start of Contour. Change the length to 0.5 and enable Extend. This will extend the start of the contour. select the Copy button to copy this to the end of the contour. This will also extend the tool half an inch past the end of the contour. Select linking parameters. Enable clearance. Change the clearance to absolute 1 inch, retract to absolute 0.25, the feed plane to 0.1 incremental, the top of stock to absolute 0, and the depth to minus 0.5 absolute. Absolute values can be defined as always measured from the origin. Incremental values are from other parameters or the chain geometry. Clearance is the height at which the tool moves to and from the part. Retract sets the height that the tool moves up to before the tool pass. Feed plane is the height the tool rapids to before changing the plunge rate to enter the part. Top of stock is the value where we set our top of stock. Depth determines the final machining depth and the lowest depth that the tool descends to into the stock. Select the OK button to generate the tool path.